Hello everybody and welcome to a new lesson from this amazing chapter of the most amazing mentorship program ever, which is, AlgoCademy's one. So in this lesson, we are going to talk about two data structures. One of them is not officially considered a data structure, and that one is the frequency array, but it is so powerful and useful that I really like to call it a data structure. And then the second one, which is the hash table, which you will see is basically a frequency array on steroids, right? So we are going to have a separate module only for the hash table, in which we are going to explain a lot more in depth how it works, what's the mechanics behind it, right? But for now, what I really need you to understand is how the frequency array works when it is used, because if you know these two things, trust me, you are going to solve every problem that involves a frequency array or a hash table, and you are going to master it, right? And let's start with the definition. What is even a frequency array? Well, as the name suggests, it is probably an array, right? Like any other array, which counts the frequency of something, how many times something appears in a collection or stuff like that, right? So the formal definition is the frequency array is an array that counts the number of occurrences of some element in a collection, right? Most often that element is an integer and that collection is an array or a list. And this being said, let's jump into the why, right? Why this frequency array? Why this amazing data structure was even designed? What problem it solves? Well, I have the problem here. We have a collection of integers, which is initially empty, right? So don't be afraid of this term collection. A collection could be an array, a collection could be a list, or anything you could imagine, right? We just have a place where a lot of integers, let's say, are there and coexist together, right? Now, we are given events of the following types. The first one is insert a new integer into the collection. The second one is remove an integer from the collection. And the third one, tell for how many times an integer occurs in the collection. So, imagine you have an empty collection, right? I'm gonna note it by this. This is an empty collection. Cool. Now, in this place, there are going to be inserted a lot of integers. And we are basically given these events in real time, right? So I don't know, imagine again that you are at some call center and you just get calls and someone says, you know what? I want you to insert me this integer into the collection right now. Or somebody might call and say, you know what? I changed my mind. I want you to remove that integer from the collection. And yeah, maybe someone calls, you know what? Tell me for how many times an integer occurs in the collection. And we need to answer these questions really, really quick. Now, one thing that I should mention is that there could be equal integers in this collection. Or in other words, an integer could appear for many times in this collection. Let's just simulate an example to really understand what I mean by this. Let's say I get the first call of the day. My boss calls me and tells me, you know what? I want you to insert the integer 3 right now into the collection. So insert 3. What am I going to do? Of course, now my collection consists of only this integer 3. Then my boss calls me again and says, you know what? I want you to also insert me the integer 5 into the collection. So the next event is insert 5. Cool. This is what I'm going to do, right? I'm going to insert 5. Now my collection consists of the integers 3 and 5. Of course, you can imagine this as an array or a list, doesn't matter. My boss calls me again and tells me, I want you to insert again the integer 3 into the collection. So insert 3 into the collection. What am I going to do? Of course, doesn't matter that 3 is already existent in the collection. I'm going to insert again another integer 3. Now I have 2 3s and 1 5 into the collection. And guess what? My boss calls me and tells me, tell me for how many times the integer 3 occurs in the collection, right? So let's write here how many 3s. Well, what am I going to tell him? Of course, I'm going to take a look into the collection and say, 2 times. Yeah, that's it. So I'm going to answer him instantly on the call and tell him 2. Then my boss might call me again and say, you know what? I want you to remove the integer 3 from the collection. So let's say my next update, my next event is remove 3. What I'm going to do? I'm not going to remove both the appearances of 3. I'm just going to remove one of them. So let's say I remove this one. Now my collection is 3 and 5. Then let's say my boss calls again and tells me, tell me for how many times the integer 4 occurs into the collection. So how many 4s? Well, none of them. So I answer him instantly and I say 0. Then the boss wants me to remove another integer from the collection, remove 5 from the collection. All right, that's it. I'm going to remove 5. Now the collection consists only of 3 and so on and so forth. You got the idea, right? Now, imagine you are that guy at the call center, right? And you're not a master of algorithms and data structures, right? What are you going to do? Well, you are going to have that collection stored somehow, right? And let's say you store it using an array or some list, right? So this is the collection. Awesome. And then what are you going to do? Well, when the boss calls and you need to insert a new integer into the collection, you are going to push that element into your array, right? So you are going to push 3. Then maybe you are going to push 5. Then maybe you are going to push 3 again, right? This is how you do. Simple as that. Then let's say the boss calls you and says, you know what? Now I want you to remove an integer from the collection. Well, what are you going to do then? First of all, you have to find an occurrence of that element, right? So let's say I have to remove 5 from the collection. What am I going to do? I'm going to start looking in the array, right? From the first element until I find an element equal to 5. This one is not equal to 5. This one is equal to 5, right? So what I should do is remove this element from the array. Now, there are multiple ways of doing that. Let's suppose our array was a little bit larger, just for the sake of the explanation. Let's say I've already pushed these elements before, right? And cool. Now I want to remove this element. One way to do this is traverse all the elements on the right of that element that you want to remove. So start with 3 and just assign that value to the previous position. So what I'm going to do here, I got my 3. I'm going to assign the value 3 to the previous element. So now this one, instead of 5, is going to be equal to 3. Then I go to the next element, which is 2, and assign value 2 to the previous position. So this one becomes 2. Then I go to the next element, assign 1 to the previous position. This one becomes 1. And I go to the next element and the last one and assign 7 to the previous position. This one becomes 7. And then I should do one more thing, and that is remove the last element as I don't need it anymore, right? And this is how my collection will look like. So basically, I am pushing all the elements after the one I want to remove one step to the left, right? And then I am removing the last element. That's one way of doing that. Unfortunately, we are making a lot of operations here. And that number of iteration is actually equal to the number of elements that we are going to traverse. So the number of elements that are on the right of the element we have just found. So yeah, you can say that this one is big O of n if we do it like this. And by the way, the first one was big O of 1, right? We just pushed one element into an array. Now, the beautiful thing here is that there is actually a smarter way to do that. And this is pretty cool. The smarter way to do that, let's take this array into this example, right? And let's say I had this collection and the boss calls me and tells me, you know what? I need you to remove the integer 2 from the collection. What I'm going to do is, first of all, find a value of 2. So I go 3, not equal, 3, not equal, and then I have 2. So I know this is the element that I need to remove. So one smarter way to do that is actually swap the element I've just found with the last element, right? So 2 with 7, this means that now this one is a 7 and this one is a 2. And what should I do next? Of course, remove the last element, right? So this is a smarter way to actually remove the element at some position in an array. But it's still not good enough. You know why? Because although this is constant, we actually have to find an occurrence of that element in order to do this. And how should we find an occurrence of that element? We were traversing the array. So this is still linear time. In the worst case scenario, maybe that element is on the last position. So I traverse each and every element in that collection. So yeah, the second one is also big O of n. Now, let's think about the third one. For how many times an integer occurs into the collection? Well, again, what I'm going to do here, because I don't know any other information, is that I'm going to traverse again the collection and maybe store a variable to tell for how many times the integer appears, right? Let's say I want to count for how many times 3 appears into this array. I'm going to have my variable, let's call it counter, right, which is initially 0. And I'm going to go and traverse each and every element. And if that value, if that current element is equal to the value that I'm looking for, I'm going to increase the counter, right? So this is a 3. I can definitely increment the counter. Then I go to the next one. This is a 3. I can definitely increment the counter. Then I go to the next one, not equal, next one, not equal. So then I finish the collection. So yeah, we are again traversing the array. So this is also big O of n, right? So you see what I'm saying? This problem is not so straightforward, and yeah, all we can come up with if we don't know about the frequency array or the hash table is linear approaches. And this is not good. So this is why the frequency array was designed. And let's see how it works. Alright, so let's first remember the definition. A frequency array is an array that counts the number of occurrences of some element in a collection. Alright, so that would be definitely helpful, right? If I always had stored somewhere for how many times each element appears, then I would be able to answer those questions super fast. And this is exactly what we are going to do. We are going to store the frequency array, which again, it's just a simple array, nothing fancy, but its definition is actually what's the most important thing here. So the frequency array of I, right? So the element on the index I is actually equal to for how many times the value I occurs into the collection. Here, in this example, I have stored an array of frequencies of length 10, right? So let's just suppose that in our problem, we are given only integers that are digits, right? So yeah, in the range 0, 9. Of course, they could be greater, but that's not the point here. I want to have the whole array, so we will definitely see how it changes, right? So now that we have this definition, I'm going to have this array, which is initially filled with 0. And why is that? Because our collection is initially empty, right? The element 0 appears 0 times, 1 appears 0 times, 2 0 times, and so on and so forth. Now let's see how simple we can handle those events using this frequency array. Let's start with the first one. I get a call from my boss, and he tells me, you know what, I want you to insert the integer 5 into the collection. Alright, boss. So 5 is now going to be part in the collection. I don't have the array for the collection. I don't need that. The only thing that I'm going to do is take a look at my frequency array, go to the index 5, and increment the value here. So now it became 1. As you can see, in this frequency array, it's pretty obvious that only the element 5 appears once, which is indeed our collection. Let's say he gives me another call. I want you to insert the value 2. Awesome. So the collection should now be 5, 2. So what I'm going to do in the frequency array, go to index 2, and of course, increment this value. Now this is 1. As you can see, 2 appears 1 time, 5 appears 1 time. I get another call, and my boss tells me, I want you to insert again the value 5 into the collection. So insert again 5 into the collection. Awesome. Now what I'm going to do, take a look at position 5, go to that element and increment its value. Now this became 2. Cool. Let's say another call, I want you to insert 7 into the collection. Awesome. So what I'm going to do, I'm going to go to position 7 and increment the number. Let's say I get a call and the boss asks me, you know what? I want you to tell me for how many times the value 8 appears into the collection. What I'm going to do? Well, of course, I know that value. Where? At position 8. What's the value? 0. So yeah, 8 doesn't appear at all into the collection. And as you can see, this is correct. Let's say I get another call. I want you to tell me how many times 5 appears into the collection. Take a look at position 5 for 2 times. So I give him the answer, which is indeed correct. Now, let's say the boss calls me and tells me, I want you to remove the value 5 from the collection. What I'm going to do? I have 2 5s. And remember, I'm only going to remove once. That's what the problem says. So I'm going to go to the position 5. And if I remove 1 5, this means that I'll have 1 5 less into my collection. So if there were 2 of them, I'm going to decrement this value. And now its value is 1. Awesome, guys. And this is how the frequency array works. It is as simple as that. The only thing that you need to do is first define that array. So store into memory an array, frequency array, which is initially filled with zeros. And then when you have an insertion, you go to that index and increment the value there. When you have a removal, you go to that index and decrement the value there. And when you are asked for how many times some value appears, you go to that index and return the value from there, right? And look how simple the code is indeed, right? So the only thing that we need to do is first define the frequency array, which is going to be an array consisting of only zeros. And for our problem, if we only deal with digits, we are going to have an array of size 10. Then all we need to do is create a function for each type of event. For the insert event, let's say we want to insert val into the collection, we are going to increment the value of frequency array of val. That's it. If we want to remove a value, we are going to, of course, decrement the value in the frequency array at that position val. And when we want to count for how many times the value val appears into the collection, we are just going to return frequency array of val. Each time we get a call, we are just going to call the proper function and get the answer so quick. Now let's compute the time complexity of our algorithm. As you know, arrays are so amazing because they are stored in contiguous memory segments. This means that we can access and even change the value of some element in constant time, right? So it's pretty obvious that all of our free functions are going to be constant time, right? We just access the value here and change the values here. So now we can really answer those calls super fast. Now, the only downside here, which is indeed a very important one, is that we need to first build this array. For our example, because I made it super simple and I suppose that we only deal with digits, yeah, okay, no problem. I just have to build an array with 10 elements. That's still constant, right? But not every problem is going to be so nice with you and tell you that you are dealing with some small numbers. In most problems, you are given an upper bound for these values. And even if you aren't given one, you can ask the interviewer and he is going to give you one, right? So the problem is going to tell you something like this. All the values that are in the events are, let's say, part of the range 0 and some value. This value could be, I don't know, maybe 10 to the power of 6, maybe 10 to the power of 9, maybe other thing, right? We are going to call the maximum value the upper bound max val, just to have like a better definition for it. So yeah, the problem is usually going to give you this value of max val, and it's not going to be always 9 as it is here. So in a general scenario where you are given the max val, we are going to build the frequency array to have length, of course, max val plus 1, because we need all the elements from 0 to max val. So I'm going to actually change this to be equal to max val plus 1. And this is the only problem with the frequency array. And this is actually the reason the hash table was designed in the first place, because it really solves this problem. But we are going to talk about the hash table in the next lesson. Now, as you can see here, unfortunately, yeah, even if we answer these queries in constant time, we still need a big O of max val just to store in memory this array. And not only in terms of time complexity, but also in terms of memory complexity. This is not always a problem. We are going to encounter problems where this max val is actually small. I mean, the problem is nice to us and tells us that max val, you know what, is at most 100 or at most 1000 or even 10,000. That's okay. We still have that kind of memory. But we are going to encounter a lot of problems, and actually most of them, where this max val is not so friendly. And yeah, it could be something like 10 to the power of 9, let's say. All the elements are 10 to the power of 9. Then not only that you take a lot of time to build an array of 1 billion zeros, but you are not even able to do that because most of the computers won't allow such a big memory use, right? So you need to be careful because the frequency array is a feasible solution only if the problem is again nice to you and tells you that you are dealing with small numbers, so you can actually store so many elements into memory. Awesome. The pretty part about this is that the hash table works exactly like a frequency array, but solves the memory problem. But we are going to learn more about that in the next lesson. Until then, I want you to really understand how the frequency array works and when it is needed. That's it, guys. I hope you enjoyed the lesson, and I'll see you on the next one. Bye.